Now I will do this question by alternative way. In this question, it is given that the vector A equal to minus I plus 2j plus k is rotated through a right angle passing through the y-axis in its way, and the resulting vector is B. Then the projection of 3a plus root 2b on the vector C equal to this is, you have to find the correct choice. Before I do this question, I will tell you a concept to be used in this question. The concept is, suppose x vector and y vector are two non-collinear coplanar vectors. Note that I am saying non-collinear also. Then any vector z lying in the plane of x and y will be of the form lambda x plus mu y. Whatever is the value of lambda and mu, this vector z will surely lie in the plane of x and y. And I will tell you one more concept also, which is not going to be used in this question, but because that is related to it, that is why I'm telling you. And that concept says that if alpha, beta, gamma are three non-coplanar vectors, note that when I'm saying alpha, beta, gamma are non-coplanar, it automatically means no two of which are collinear. Because if any two are collinear, then the three vectors will become coplanar. Also note that I'm dealing with free vectors. And in mathematics of JEE level, we usually have to deal with free vectors only. The other type of vectors are localized vector. In localized vector, some other conditions also come, but presently I am dealing with free vectors only, and in most of the questions of JEE level you will be dealing with free vectors only. And now the concept is, if alpha, beta, gamma are three non-coplanar vectors, any vector lambda can be written as x alpha plus y beta plus z gamma, where x, y, z are scalar. Again I am telling you, if alpha, beta, gamma are three non-coplanar vectors, then any vector of three-dimensional space can be written as linear sum of alpha, beta and gamma, that is in this form, where x, y and z are scalars. And the proof of all these things you can understand if you are clear about the concept of linearly dependent vectors and linearly independent vectors. That is the whole theory I have told you so far. For the detailed concept of that theory, you will have to see my video lecture of vector algebra of JEE level. And now, according to the information given in the question, it is clear that B vector lies in the plane of A and Y axis and is perpendicular to A vector. Hence, because B vector is lying in the plane of A vector and Y axis, hence I can say B vector is equal to alpha A plus beta j. Note that j is a vector along y axis. I will find the value of alpha and beta with the help of these two conditions, that mod of beta is equal to mod of a, and second condition is b dot a equal to 0. And these things I am going to use for finding the value of alpha and beta. And now I take dot product with a vector on both sides of this equation, and I will use this thing, that is I will be getting b dot a equal to alpha a dot a plus beta j dot a. B dot a is 0 according to this condition. Alpha a dot a according to this will be 1 plus 4 plus 1 plus beta into, from here it is clear that j dot a will be 2. Hence I get the conclusion that beta plus 3 alpha equal to 0. And now taking beta equal to minus 3 alpha, and the value of beta I get from here, that is minus 3 alpha, I will be putting here, and then I will use the condition that mod b equal to mod a, that is beta equal to alpha a minus 3 alpha j, that is b vector is equal to alpha I plus 2j alpha into minus I plus 2j plus k minus 3 alpha j, that is I get beta equal to alpha into minus I minus j plus k. Hence mod b equal to mod alpha into 1 plus 1 plus 1, and we know that mod a equal to under root 1 plus 4 plus 1, that is root 6, and clearly mod b equal to mod a implies that mod alpha into root 3 equal to root 6, that is mod alpha equal to root 2, that is alpha equal to plus minus root 2. And now taking alpha equal to plus minus root 2, I will be getting two values of b, that is root 2 into minus I minus j plus k. And because it is given that b vector is rotated through an angle of 90 degree, and while rotating it is passing through y axis also, then it clearly means that the vector b will be making acute angle with y axis. Hence, for finding the correct value of b vector, I will have to take minus root 2 outside, because I require the coefficient of j as positive, and by taking minus root 2, I'll get the coefficient of j as positive. Hence the value of vector b becomes root 2 into I plus j minus k. Once the value of vector b is known to you, further it is easy. Put the value of vector b here, and remaining procedure is same as I told you in the previous way.